Okay, let's do an example. It says change the order of integration and then evaluate. And we're given these two double integrals. The first one goes from 0 to 1, 0 to 1. Second one goes from 1 to 2 on the outside and y minus 1 to 1 here. They both have the same integrands. So we're going to graph the region that corresponds to the first one and second one. Okay, so let me make some observations. So note. Okay, so in the first double integral we have x goes from 0 to 1, y goes from 0 to 1. On the second one we have the y is going from 1 to 2 and the x is going from y minus 1 to 1. Okay, so let's start. Well, actually, let's set x equal to y minus 1 and solve for y, say. Okay, so y minus 1 equals x, then adding 1 to both sides, y equals x plus 1. Okay, now let's try and graph these two regions. Okay, so let's do that. So graphing this guy here, 0 to 1, 0 to 1, to just make this square. And then looking at this guy, well, this is saying y goes from 1 to 2, and then x goes from y minus 1 to 1. So let me try and graph that now. So I put my 1 to 2 here for the y. So let's next note, when y is 2, then putting 2 in place of y minus 1 here, you'd have that x would have to be 1 in that case. Let me just make an observation there. So note when y is 2, so putting 2 in place of y here, then y minus 1 would be 1. But x is between y minus 1 and 1, so y minus 1 is 1, and you got 1 on this side, that forces x to be 1. Okay, so we know then you'd have a point right here. Okay, now let's find when y is 1, what happens. So letting y be 1 here, then you'd have 0. So you'd have 0 less than or equal to x, which is less than or equal to 1. So pretty much be going all the way across here. So it's like it'd be starting here. So you can draw in this then. So to figure out whether it's on this side or this side, so let's take a look here. I claim it's going to be on this side. Let me explain. Because you can see that when y is 1, we already established x goes from 0 to 1, which is 0 to 1. And when y is 2, we mentioned that x has to be 1, so it's here. So it had to be in here then. This is our region here that we're talking about. Okay, we're going to take this away now. So that's our. So putting the two regions together, we get this. All right. So now we're going to change the order of integration. So right now, on these two integrals here, we're taking strips this way. We had a strip down here like that, and a strip up here like that. This one down here corresponds to this first integral. The one up here corresponds to the second one. And now we're going to change the order of integration. So we're going to do vertical strips this time. Let me erase these. So we're going to be doing vertical strips like this. You can see here it's only going to require one double integral. It won't require two like up here. So let me summarize. Okay, so here's my region. So here's the thing we're trying to integrate. So now I'm switching order of integration. I'm doing dy dx. So we're going to be doing vertical strips. Let me draw in the vertical strip here. So drawing the vertical strip, it's going to go from 0 up to the line, and we found that the equation of that line was y equals x plus 1. So let me write that here. So it's we found out it was y equals x plus 1. So therefore the y is going to go from 0 to x plus 1, and the x is going to go from 0 to 1 on our limits here. So let me write those here. So I've written them here. So again, you go from 0 to x plus 1, and then 0 to 1. Okay, now we're integrating with respect to y first. I can do that, so let me do that. I'm going to erase this region now and integrate, so it's going to be y squared over 2 here. So let me erase this now. So integrating the y, it'll be y squared over 2. This guy will come along. They're going to evaluate at 0 and x plus 1. So I'm going to put x plus 1 in place of y, and put 0 in place of y. So let me write it down here. So doing that, we get distance. So again, I'll put x plus 1 in place of y, so it'll be x plus 1 squared over 2. Now I'm going to make a u substitution. I'm going to let u equal the x plus 1 cubed plus 5. So let's do that. So letting u equal the x plus 1 cubed plus 5, then du dx. So it'll be, take the 3 down, subtract 1, multiply by the root to the inside, which is 1. The 5 goes away. So then multiplying both sides by dx, you'd have du equals this. And then I solve for x plus 1 squared dx because I have it over here as equal to du over 3. So now let's make the u substitution. So making the u substitution, I get u of 0 to u of 1 on my limits of integration, and 1/6 u to the 1/2 du. Again, how I got that was the x plus 1 squared dx part is du over 3, and you have 1/2 here also, so multiplying those will become 1/6, and this will become square root of u, but you can write that as u to the 1/2. Okay, so then u of 1, my u is up here, so putting 1 in there, so it'd be 1, so it'd be 2 cubed, it'd be 8 plus 5, 13, so this guy would be 13, and putting 0 in there ended up being 6, it looks like. Okay, so let me do that. Okay, so we get 13 for u1, 6 for u0. Then let's integrate the u to the 1/2, so adding 1 to the power, dividing by a new power. So let me write it over here. So integrating the u to 1/2 becomes 2/3 u to 3/2. And it's going to be evaluated from 13, evaluated at 13, subtract evaluated at 6. So let me write that here. Also, I guess the 2 will cross off, but a 6 here and become a 3 here. So it's going to become 1/9 down here. So let me write that. Okay, so it becomes then 1/9 in front. Then putting 13 in there will be 13 to the 3/2. Then putting 6 in there, minus 6 to the 3/2. Whatever that is, it doesn't. I'm just going to leave it like this, my answer. This is our answer here. Okay, so we're done. So again, just to summarize, initially we were unable to integrate these, doing dx, dy. So we graphed a region, switched to order of integration, and then we were able to integrate it and get our answer. Okay, so we're done.